Angle modulated signal with a carrier frequency omega c, that is 2 pi into 10 power 5 radians per second, described by the equation pi suffix fm of t. We have to find out the frequency deviation ratio. So first of all, in order to find out frequency deviation ratio, what does it mean? Frequency deviation ratio, you see, if a single sinusoidal signal is FM modulated, then we call it as a modulation index beta. If multiple sinusoidal signals are modulated on a single carrier, then we call the modulation index as the frequency deviation ratio. Okay, so frequency deviation ratio beta is nothing but frequency deviation by maximum frequency in the modulating signal. Here delta f r, we can delta omega by omega m also we can write. Here delta omega is, omega I is nothing but omega c plus delta omega. Omega is the instantaneous frequency. Now omega I is d by dt omega ct plus 5 sine of 3000 t 10 sine of 2000 pi t. So delta omega max is equals to 15,000 plus 20,000 pi. Okay, then omega max is nothing but 2000 pi. Hence beta is equals to delta omega max divided by omega max, which is equals to, after substituting the values which we got above, we are going to get 12.38. Hence option D is correct. Now we have to find out the bandwidth of the given frequency modulated signal. So here bandwidth for the frequency modulated signal is given by the Cosen's rule, that is bandwidth is equals to 2 into frequency deviation ratio plus 1 into maximum frequency FM. Now all the values we have, beta is 12.38, FM is 1000, that is the maximum frequency means omega max by 2 pi hertz. So if we substitute the values which we got here, then we will get bandwidth as 26.7 kilohertz. Hence option B is correct. In bandpass filter, the lower and upper cutoff frequencies are f1 equals to 2 Hz and f2 equals to 6 Hz respectively. Input signal is u of t equals to 3 e power minus 2t u of t volts. Compute the 1 move energy of the input. Energy of a signal is found by finite to infinite. Energy of a signal x of t is found by x of t whole square dt in frequency domain 1 by 2 pi minus infinite to infinite x of omega whole square d omega. Here, so energy of u in of t is found by minus infinite to infinite 3 e power 2t whole square dt. So 9 minus infinite to infinite e power 4t dt. Signal is existing from 0 to infinite because it is multiplied by a right-handed signal, that is u of t, which exists from 0 to infinite. Minus infinite to 0, the value of u of t is 0, hence the integral is 0. Now 9 by 4, which is 2.25 joules, hence option A is correct. The percentage that appears at the output, the percentage that appears at the output here means we are passing a signal x of t to the output via means output. We have to find out the what is the means we have to find out the energy of the y of t. Then we have to find out what portion of x of t is appearing at the output of the filter. We know that y of omega is x of omega h of omega. Here h of omega is a band pass filter, 2 Hz to 6 Hz. In radians, 4 pi to 12 pi radians, magnitude is 1. So it is x of omega in bit x of omega 4 pi radians to 12 pi radians. So energy of y is nothing but 1 by 2 pi 4 pi to 12 pi 3 by omega square plus 2 square whole square d omega. So it is equals to 9 by 2 pi 1 by 2 tan inverse of omega by 2 4 pi radians to 12 pi radians. If we solve this one, we will get 0.8 joules. So the percentage that appears at the output is EY divided by EU in into 100. That is 0.08 joules divided by 2.25 joules into 100, which is equals to 3.56%. Hence option A is correct.